It feels like we're walking on a wire. Not just us as people, but the whole universe. Everything from the tiniest atom to the biggest galaxy seems to be balanced on a razor's edge. If you nudge one little thing, even slightly, the whole show collapses. And the strange part is, this delicate balance seems perfectly set up for life for us. This is often called the fine-tuning problem, and it's one of the biggest, most mind-bending questions you can ask. It's not a question with an easy answer. It sits right at the border of physics and philosophy, and it makes people on all sides of the debate feel a little uneasy. So, what does it mean? Think about baking a cake. You need the right amount of flour, sugar, eggs. The oven needs to be at the right temperature. You have to bake it for the right amount of time. If you get the temperature wildly wrong, you don't get a slightly bad cake, you get a lump of charcoal or a gooey mess. You don't get a cake at all. The universe is like that, but with much higher stakes and much finer tolerances. The ingredients are the fundamental constants and quantities of nature. These are the numbers that are just sort of given in our physical theories. They are the strength of gravity, the mass of an electron, the speed of light, and a dozen or so others. Physicists measure these numbers with incredible precision, but they can't tell you why they have the values they do. They just do. And here's the spooky part. If you play a game with these numbers, if you imagine a universe where one of them is just a tiny bit different, you almost always get a universe that is sterile and dead. A universe with no stars, no planets, no chemistry, no complexity, no life. Let's get real and look at a few of these dials that seem to be tuned just for us. One of the most famous is the force of gravity. It feels strong to us. It keeps us stuck to the Earth and holds the solar system together. But in the grand scheme of the fundamental forces, it's astonishingly weak. It's about 1,000 billion times weaker than the electromagnetic force, the one that stops your hand from passing through a table. What if gravity were a little stronger? Say a billion times weaker instead of 1,000 billion times weaker. It sounds like a small change, but it would have catastrophic consequences. Stars would burn hotter and much faster. A star like our sun, which was meant to last for about 10 billion years, giving life plenty of time to evolve, might burn out in 1,000,000 years. That's not nearly enough time for anything interesting to happen. The universe would be a flash in the pan. Animals, if they ever got started, wouldn't have time to grow to a large size because the crushing force of gravity would be too much for any complex bone structure to handle. Okay, so what if gravity were weaker? You'd have the opposite problem. The primordial clouds of gas after the Big Bang would not have had enough gravitational pull to clump together. They would just disperse. You'd get no galaxies, no stars, no planets, just a thin, cold, boring soup of hydrogen and helium gas expanding forever. The strength of gravity seems to be tuned in a very narrow, life-permitting range. A bit more, and it's all over too fast. A bit less, and it never gets started. Then there's the strong nuclear force. This is the force that glues protons and neutrons together inside the nucleus of an atom. It's the reason we have more than just hydrogen in the universe. Its strength is also on a knife's edge. If the strong force were just 2% weaker, protons and neutrons wouldn't stick together. The deuteron, a combination of one proton and one neutron, would be unstable, and the deuteron is a crucial stepping stone in the nuclear reactions inside stars that create all the heavier elements. Without stable deuterons, you get a universe with nothing but hydrogen. No carbon, no oxygen, no nitrogen, and no life. But if the strong force were just 2% stronger, it would be too good at its job. Protons would stick together so easily that in the searing heat of the early universe, all the hydrogen would have been fused into heavier elements almost instantly. There would be no hydrogen left to serve as the long-lasting fuel for stars like our sun. Again, no sun, no heat, no light, no life. The dial for the strong nuclear force is set just right to allow for both hydrogen and a rich variety of other elements to exist. We can keep going. The mass of the neutron is slightly heavier than the mass of the proton. It's a tiny difference, about 0.14%, but it's a critical difference, because it's heavier. A free neutron will decay into a proton, an electron, and a neutrino in about 10 minutes. If the proton were the heavier one, it would be the one to decay. Stable hydrogen atoms, which have a single proton as their nucleus, wouldn't exist. Without stable hydrogen, you have no water, no stable stars. The entire basis of chemistry and life as we know it would vanish. The universe would be a bizarre radioactive wasteland of decaying protons. Perhaps the most staggering example of fine-tuning is something called the cosmological constant. This is a number that represents the energy density of empty space itself. It's the thing that's causing the expansion of the universe to speed up. When physicists tried to calculate what its value should be based on our best theories of particle physics, they got a number that was absurdly large. It was one with 120 zeros after it. That's a 1, followed by more zeros than there are atoms in the Earth. But when astronomers actually measured the cosmological constant by observing distant supernovae, they found a number that was incredibly small. It was close to 0. The observed value is about 10 to the power of 120 times smaller than the theoretical prediction. This has been called the worst theoretical prediction in the history of physics. Why does this matter for life? If the cosmological constant were as large as theory predicts, the repulsive force of empty space would have been so powerful that it would have ripped the universe apart in the first fractions of a second after the Big Bang. It would have overwhelmed gravity completely. No structures would have formed, no galaxies, no stars, no planets. Nothing. The universe would have expanded so fast that everything would be instantly diluted into nothingness. To get a universe like ours, one with galaxies and stars, the cosmological constant has to be tiny, tiny, tiny. It has to be fine-tuned to an accuracy of 1 part in 10 to the 120. To give you a sense of how precise that is, imagine trying to throw a dart from one side of the observable universe to the other and hitting a bullseye 1 millimeter wide. That's the kind of precision we're talking about. It's a number that, from the perspective of physics, looks like an absurd, arbitrary, and highly unlikely accident. There are more examples. The initial conditions of the Big Bang had to be just right. The universe started in a state of very low entropy, meaning it was highly ordered. It's like it started with all the sand on the beach in one perfect sandcastle, and it's been eroding into a messy, disordered state ever since. This initial order is what allows for complexity, like stars and life, to form. Why did it start so ordered? No one knows. If there had been a slightly different balance between matter and antimatter in the early universe, everything would have annihilated, leaving behind a universe filled with only light. No stuff. So, we are left with a universe that appears to be balanced on an impossibly thin wire. The constants and conditions of the cosmos are not just good for life, they seem to be radically, preposterously, shockingly perfect for it. This brings us to the big question: why? Why is our universe like this? Why is it a life-permitting cake and not a lump of cosmic charcoal? This is where the ground gets shaky and science starts to bleed into philosophy. There are basically a few major lines of thought, and none of them are entirely satisfying. The first and most ancient explanation is a designer. This is the idea that the universe is the way it is because someone or something made it this way on purpose. A creator, a god, an intelligence beyond our comprehension set the dials. This intelligence knew what it was doing. It wanted a universe with complexity, with stars, planets, and beings who could observe it. So it adjusted the strength of gravity, tweaked the mass of the neutron, and set the cosmological constant to that absurdly small number. This idea has an intuitive appeal. When we see something that looks designed, we tend to assume there's a designer. If you found a watch on the beach, you wouldn't assume the wind and the waves randomly assembled it from sand. You'd assume a watchmaker made it. The universe, with its intricate laws and life-permitting constants, looks a lot more complex than a watch. So the argument goes, it must have a universe maker. The strength of this explanation is that it directly addresses the why question. It says the universe is finely tuned because it was intended to be. It provides a reason for the apparent coincidence. The problem with this explanation from a scientific point of view is that it's not testable. You can't run an experiment to prove or disprove the existence of a cosmic designer. It takes the problem outside the realm of science and puts it into the realm of faith and theology. It also raises the difficult question, who designed the designer? If the universe is too complex to exist without a creator, then isn't an intelligence capable of creating a universe even more complex? It explains one mystery by invoking an even bigger one. For many scientists, this is not a satisfying answer. Science looks for natural explanations for natural phenomena, so they have looked for other ways to explain the fine-tuning. The second major explanation is the multiverse. This is probably the most popular idea among physicists today. It's a wild one, but it has a strange kind of logic to it. The idea is that our universe isn't the only one. There are other universes, maybe an infinite number of them, and in each of these universes, the fundamental constants of physics are different. Imagine a giant cosmic bubble machine. It's constantly spitting out new universes. In one universe, gravity is strong, in another, it's weak. In one, the strong nuclear force is powerful. In another, it's feeble. In one, the cosmological constant is huge. In another, it's negative. Almost all of these universes are dead. They are born and they die in an instant, or they are empty and cold, or they are filled with black holes. They are sterile, But if you have enough universes, if you have an infinite number of them, then just by chance, some of them are going to have the right combination of settings. Some of them will have gravity that's just right, a strong force that's just right, and a cosmological constant that's just right. In those universes, stars will form, planets will coalesce, and life can emerge. This idea is often paired with something called the anthropic principle. In its weak form, the principle is basically a tautology. It says that we should not be surprised to find ourselves in a universe that is compatible with our existence, because if our universe were not compatible with our existence, we wouldn't be here to observe it. It's like asking why you happen to live on Earth, the one planet in our solar system that has liquid water and a breathable atmosphere. Is it a miracle? Not really. You live on Earth because you couldn't live on Venus with its crushing pressure and sulfuric acid rain, or on Mars with its thin, cold atmosphere. Your existence as a water-breathing, oxygen-dependent life form pre-selects the kind of planet you will find yourself on. The multiverse and the anthropic principle apply this same logic to the entire universe. We shouldn't be surprised that the constants are fine-tuned for life. We have won a cosmic lottery. But it wasn't a single ticket lottery. It was a lottery with an infinite number of tickets, and every possible combination of numbers was printed on one of them. It was inevitable that one ticket would be a winner, and as the winners, we were the ones asking the question. All those other universes, the sterile and dead ones, have no one in them to wonder why things are so bad. The idea of the multiverse isn't just a philosophical get-out-of-jail-free card. Some of our best theories in physics, like string theory and eternal inflation, actually predict the existence of a multiverse. So it has some theoretical backing, but it has problems too. The most obvious one is that, like the designer hypothesis, it's very difficult, maybe impossible, to test. How could we ever get evidence of another universe with different laws of physics? They are, by definition, causally disconnected from our own. Some critics say it's not real science because it's not falsifiable. They also argue that it's deeply unparsimonious. To explain the apparent fine-tuning of one universe, you have to invent an infinite number of other, unobservable universes. It seems like a very heavy price to pay. So we have two grants: sweeping explanations, a cosmic designer, or an infinite cosmic lottery. What else is there? Third possibility is that we are just missing something. Maybe there is a deeper physical law, a theory of everything that we haven't discovered yet. And in this deeper theory, the constants of nature are not arbitrary at all. Maybe they have to have the values they do. Maybe there is only one mathematically consistent way for a universe to exist, and it just so happens to be this one. In this view, the dials are not really dials. They are more like the number pi. Pi is not something you can just change. It's fixed by the nature of geometry. The ratio of a circle's circumference to its diameter has to be 3.14159. It can't be anything else. Perhaps the strength of gravity and the mass of the electron are like that. Perhaps they are derived from some more fundamental principle, and their values are fixed by logic and mathematical consistency. If this were true, it would mean the universe is not finely tuned. It's just tuned! There's only one way it could be, and that way happens to allow for life. This is the great hope of many physicists. It would be the ultimate triumph of science to show that the universe we live in is the only possible one. The problem is we don't have this theory. String theory was once a candidate, but it seems to predict a landscape of 10 to the 500 possible universes, which puts us right back in multiverse territory. For now, the deeper law explanation is just a hope. It's a promissory note, and it might also just push the problem back a step. Even if a deeper law explains why the constants are what they are, we could then ask, why is that law the one that allows for life? Why is the one and only mathematically consistent universe a life-permitting one? This leaves us with a fourth, and perhaps most unsettling possibility: brute fact. This is the idea that there is no explanation. The universe is the way it is, and that's it. It just happens to have these values. We won the cosmic lottery on the very first ticket. It was an accident. A wild, improbable cosmic fluke. This is deeply unsatisfying to our human desire for meaning and explanation. It feels like giving up. But it is a logically coherent position. Not every why question has an answer. Maybe there is no deeper reason. Science can describe the universe with incredible accuracy, but maybe the question of why it exists at all, or why it has these particular properties, is not a scientific question. It just is. Of course, we should be careful here. We should also question the premise itself. Is the universe really as finely tuned as it seems? Some scientists and philosophers argue that we might be suffering from a failure of imagination. We assume that life has to be like us based on carbon and water orbiting a stable G-type star. This is sometimes called carbon chauvinism. Maybe life could exist in radically different forms in universes with different physical laws. Perhaps there could be life based on silicon in a methane sea orbiting a dim red dwarf star. And maybe in a universe with stronger gravity, life would just be smaller and tougher. Maybe in a universe with only 2 dimensions, some other form of complexity could arise. The problem is that it's very hard to imagine how. The conditions for complexity seem to be much more general than just carbon and water. You need a universe that lasts long enough. You need stars that can produce heavy elements. You need a stable source of energy. You need chemistry that is complex enough to store information. When you change the physical constants, you usually don't just get a different kind of life. You get no stars, or no chemistry, or a universe that lasts for a microsecond. You get a universe that is fundamentally simple and boring. Another objection is that some of the constants might be linked. Maybe if you change one, another one automatically changes to compensate, keeping the universe stable. This would reduce the number of independent deals that need to be tuned. This is possible, but so far our best physical theories treat these constants as independent. We have no reason to believe they are linked in such a convenient way. So where does that leave us? We stand in a universe that looks suspiciously like it was made for us. The laws of physics seem to have been carefully selected from a vast sea of possibilities to permit the existence of observers. We are faced with a profound mystery. The options on the table are all mind-stretching. 1. It was designed. A cosmic intelligence set the stage for us to appear. This is a matter of faith beyond the reach of science. 2. It's one of an infinite number of universes. We are in one of the rare, life-friendly ones because we couldn't be anywhere else. This is a scientific hypothesis, but one that may be forever untestable. 3. We're missing the bigger picture. A deeper, undiscovered law of physics dictates that the constants must be what they are. This is a hope for a future scientific revolution. 4. It was just a fluke, a stupendously improbable lucky accident. There is no deeper reason. None of these answers are comfortable. They all challenge our sense of our own place in the cosmos. To believe in a designer requires a leap of faith. To believe in the multiverse requires us to accept the existence of an infinite number of unseen worlds. To believe in a deeper law requires us to have faith in the power of physics to one day explain everything. And to believe in a brute fact requires us to live with the possibility that our existence is a meaningless, random accident. The fine-tuning problem doesn't give us an answer. What it does is frame the question. It forces us to confront the strangeness of our own existence. It shows us that the world we take for granted, the solid ground, the warm sun, the air we breathe, the very atoms that make us up, is built on a foundation of physical laws and constants that are balanced on an impossibly fine edge. To be alive, to be aware, to be able to look up at the night sky and wonder about these things is to be a participant in something that looks like a miracle. Whether that miracle is the product of chance, necessity, or design is the question that sits at the heart of science, philosophy, and what it means to be a thinking being in this strange and finely tuned universe. We don't have the answer, and maybe the search, the wondering itself, is the point. The universe has allowed us, against all odds, to ask the question, and that is a remarkable thing.